Hi guys, 9-9. We're going to start a new, not the new idea. It's going to be the same sort of idea, but we're going to do something interesting with it. We're going to say what? We've been going around the axis nonstop, right? What if we have the crazy idea, instead of actually going around the axis, what if here's our normal axis down here, right? What if we just decide to rotate this parabola instead of around the axis, but around some other random line? Surely we can do that. If you look down below, that's the shape you would get, right? You could see the shape you would get. It's this shape. Well, let's see if I can find it. Okay, remember, it's this shape here, right? Because you're rotating around one. The whole thing would be above the axis. So how the heck am I going to do this? The answer to the question is, you're using the same thing. What's the same thing? What do I mean by the same thing? What I mean by the same thing is, like, say, look, you still are integrating circles. So it's pi, the radius of the thing with respect to x, because I'm walking in the x direction, squared dx. That has not changed. What's happening here, though, is my radius has to be more carefully thought about. Because my radius is no longer all the way down to the axis, my radius stops here. It's literally just the function r of x, the function that we have, or f of x. Let's use f of x because it's a little clearer here. Minus 1, right? However high this point is in terms of y, minus 1, because it doesn't go all the way to the axis, it's going to be all the way to the axis minus the 1, right? That doesn't make it, right? So whatever this is, which would be our f of x, minus 1. That's it. Hit that, square it, and you're good to go, dx, okay? So then moving forward, I would then simplify this a little bit. I would say, all right, my function here is written as 2 minus x squared. So I'm going to go 2 minus x squared minus 1 squared dx. Pi integral. And then I'm going to get negative x squared plus 1. Clean that part up, dx. I'm going to keep going through my integral here. Oh, by the way, where am I starting? If I check my parabola, it tells me negative 1 and 1, so I'm just going to go ahead and use their values they give me. Although I could solve for those, I could definitely do that. So x to the fourth minus 2x squareds. I lost my train. Oh, I'm down there. Okay, plus 1, right? Dx. And so then it's just a matter of solving this monstrosity, pi, parentheses, x to the fifth over 5, minus 2/3 x to the third, plus x from negative 1 to 1. And clean this up, I get pi 1/5 minus 2/3 plus 1 minus parentheses, plug a negative 1 in there, I get negative 1/5 plus 2/3 minus 1. I recognize these are symmetric, and I got a minus sign, so the exact same things. End up with 2/5 because 1/5 minus 1/5 is minus a negative 1/5 is 2/5 plus 4/3 or minus 4/3 plus 2. Pi out in front. Do just a little bit more math on this. I need to do everything in terms of 15ths, so this is going to be pi times 6/15 minus 20/15 plus 30/15. So that gives me 10 16/15, I think. Nope. Yep, 16/15. So 1 and 1/15 pi. Let's hope that's the same answer as on your sheet. If not, it's a math error and not a big deal. So my approach is this. My approach is going to be, if I'm going to have a function, I'm going to rotate around something other than the axis, well, then all that's going to have is my function minus whatever I'm rotating around becomes my new distance, right? My new radius of my big shape. So for example, if I was rotating around down here, let's say negative 1, my shape would be huge, right? It'd be this big old thing wrapped around. It would be a massive shape. So how do I find my radius? Same thing. It's going to be this function, whatever this is, minus a negative 1, right? Because I'd be minusing the thing I'm rotating around. So we minus a negative 1, so I end up being plus 1 and make it even bigger. Okay? So ultimately, the way this is going to work is you don't even have to think about it. That's the part that's frightening. As long as you're going around a function that is, for example, this case, y equals 1, you're just going to, whatever the function is, minus whatever it is, whatever you're rotating around, squared. So in general, it's going to look like this. It's going to look like whatever the, let's try it again. Okay, so whatever the function is, f of x, rotating it around y equals a, my integral is going to be f of x minus a squared dx. Now, some of you that are really thinking out loud, and I really appreciate this, what if the function looks like this? I got a function down here, and I'm rotating around y equals a way up here. Well, what happened in that case, technically, is this. You would end up going, aha, completely different, Mr. Resny, because of this, correct? It would be a minus f of x would be my radius. But look carefully, I got a square on this, right? If I've got a square on this, then what's ultimately going to happen is I'm going to realize that it's an absolute value bar, right? So what if I do put it in backwards? What's the difference? None, right? The negative becomes positive, positive, negative. If my a is bigger than my f of x, yeah, technically I should do it this way, but it doesn't matter because I'm going to square it, and it's going to be absolute value, and it isn't going to matter. Okay, with that in mind, I'd like you to do 12b, not 12a, 12b. Jump all the way to 12b, because we've got other things to discuss before we do 12a. So try 12b right now. Try 12b, and I will join you right away. Here we go. I haven't tried 12b yet. You should try it right now. This isn't like what we were doing before, so hopefully this is just going to be a reminder for you. You've got your shape right here. Boop, boop. I've got my parabola that looks like this. I've got this drop down. I've got my y-axis is this. Oh, y-axis is this thing right here. My x-axis is, don't know, I'm looking for x over x equals 2. So here is my shape. Agreed? Alrighty then. So here is my shape. Okay. So, can I do this problem? Absolutely. We've been doing this problem all along because this is the x-axis. You're like, Mr. Resny, we're talking about rotating around something other than what we're used to. Fine, let's do that right now. Let's talk about how to rotate around the x-axis. So we're going to go ahead and go, oh, well, this is something we've been doing all along. Pi, my function is 2x squared. Now, if I wanted to right now and I wanted to have fun, I could say, but aren't we rotating around the y equals 0 line? Aha! It's the same thing, correct? Same thing. And then we're going to go pi. Where does it start? It starts at 0, ends at 2, because we're walking through circles in this direction. So we go pi, integral from 0 to 2, 4x to the 4th dx. And then I'm going to go ahead and go pi, 4/5 x to the 5th from 0 to 2. So that's going to be 32, something really large. 32, 128 pi over 5, which I could simplify in some way, minus 0. So this is just going to be 128 pi over 5. Agreed? All right, so the next thing we're going to do is D. We're going to do problem number D. So do 12D now, okay? 12D. Try that out. Pause this up. Try 12D, and then we'll see how we do. All right, you should have tried 12D by now. So 12D. So if you've not tried 12D, pause it. Try 12D. If you have tried it, here we go. Check my pen. See if my pen's working. Pen's not working, so that's a bad sign. Okay, here we go. So I'm now going to rotate around the x equals 2. That's this thing right here. So we are walking in the y direction because we're walking over x equals 2. So we're going to walk that way. Our circles are going to be this way, flat in the plane, and we're walking upwards, correct? Because this thing's rotating around x equals 2. So you go, oh gosh, all sorts of problems. But we can do this. Don't panic. We've got this. So we're simply going to remember that we're going to do pi integral r in the y direction, our function in the y direction, minus, we're not going around the axis, we're going around 2, so I'm going to throw a little 2 right there, squared dy. Woo! Now I got to figure out where I'm going to start my graph and end my graph. I'm going to start at 0, that's easy enough. But how far do we go in the y direction? I plug a 2 into my function, I get 2 squared is 4, so this point up here is the point 2 comma 8. So I'm going to end my graph when I get to 8. Now I got to switch my graph around because my function's not working. So y equals 1/2 divided by 2 equals x squared. So in other words, I'm going to solve for what y is equal to, sorry, what x is equal to, right? Because I'm going in the y direction. X equals plus or minus the square root of y over 2. Now, interestingly enough, one of those is the back side of this graph, one's the front side of this graph, so it doesn't matter which one I pick. So I'm going to go ahead and pick the square root of y over 2 part. So I'm going to go pi integral from 0 to 8. Square root, so I'm going to do y to the 1/2 power over the square root of 2, right, to make my life just a smidge better, minus 2 squared dy. All right, so that's the big picture. That's the big item. That's what we have to be able to do. We're walking in the y direction, boom, because we're going around to x equals 2, so this thing is rotating this way around the axis, so my circles are in that direction. I recognize I'm starting at 0, ending at 8. I have to change my formula, which is annoying. And then it's just, since I'm not going around 0, I have to go around 2. So therefore, we're going to go ahead and try that. We just throw a minus 2 in there, because that's what we do. Because technically what we're doing is we're doing this is our new radius, right? Our function in terms of y, essentially our x value, minus the 2, which is the line we're going around. So my radius would just be this little piece right here. All right, so here we go. We'd solve this thing up by doing just basic work, hopefully. I don't know, I'm probably going to get this wrong. This is 0 to 8, so I'm going to FOIL that first. So I FOIL that first, I'm going to get 1/2 y minus 2, so minus 4 over root 2 y to the 1/2 power, that's fun, plus 4 dy. So I'm going to go pi integral of, I'm going to raise this power by 1, divide by power I get, so I got y squared over 4 minus raise this power by 1, divide by the power I get, 2/3, that's 8 over 3 root 2 plus 4y. And I'm going to do that from 0 to 8. So the first thing becomes 64/4, which is 16, minus, plug in an 8 here. The square root of 8 is 2 root 2. So I'm going to get 8 over 3 root 2 times 2 root 2 times 2 root 2 times 2 root 2. So notice, when I put in the 8 in there, I get square root of 8, which is 2 root 2 if I simplify it. I got cube that, so I've got that sitting there for simplifying purposes, then 32 minus 0, because when I plug in zeros, I get a whole bunch of zeros, boom, parentheses. And so then pi 16, let's go ahead and add those two up, 48 minus, one of these cancels out with the bottom, and these two make another 2, so that gets me 2, 4, 6, 8, 64/3. So simplifying that, I'm going to get 48/3. That's a 120. Not fun to do in my head. All right, pi 48 would be 120, 144/3 minus 64/3. So I'm going to get 80/3. 80/3 pi. All right. And that's the end of this video, whether I like it or not, because time is up. Okay. So next up, read the rest of your assignment. Do only the problems I ask you to do. There are some glitches. We will get to those next time, but just need to do a couple of these problems before we jump into the next idea. And so we'll jump into the next idea next time.